At Simio, we're in the business of showing you the future. Our intelligent technology gives you unprecedented insight into complex systems to identify and solve today's inefficiencies and tomorrow's challenges. The Simio solution provides a low-risk opportunity to drive transformational change. Our true digital twin models capture all the constraints, business rules, and decision logic that define the operation of your system. When powered by your data, easily evaluate unlimited scenarios and deliver optimized solutions. No matter what industry you're in, eliminate your greatest operational process and scheduling challenges with a Simio digital twin. See your future success, Simio.
Welcome, everyone, to the Simio Solutions Series, our April edition here. Let me jump right into it. My name is Dan Vasilini. I'm the VP of Global Sales over here at Simio. Today, doing most of the presenting is going to be Adam Sneath. He's one of our senior solution engineers, and anyone that's familiar with Simio has probably talked to Adam at one point or another. He makes his way around the Simio community pretty well. Today's topic is going to be warehouse modeling techniques and best practices. You will see this QR code a few times throughout this presentation. I do ask that at some point, whether it's now, and I will flash the QR code one more time at the end, if you could just scan that code with your phone and do a quick survey for us, we'd appreciate it. We're always looking for feedback on our solution series. We have received some pretty good feedback once we started putting this QR code out there. So we ask that anyone that would be interested, please provide us your input on today's and any future sessions. Let's jump into it. First off, for housekeeping purposes, today's session is being recorded for replay purposes. If you'd like to rewatch this session in the future or rewatch any other session we've done in the past, or refer this on to a friend or colleague, or just simply want to watch something in the evening, feel free to go to simio.com, and this session, as well as all the other sessions, will be published there. All previous sessions are already there. Usually it takes us about 24 to 48 hours to get today's session up and running. So if you are anxious to re-watch this after you've already watched it, give us usually, like I said, about 24 hours or so, and it will be there. So by the end of the week, you can expect you'll see the actual recording on there. Also, be alert that all participants do enter on mute, so you are muted during today's session. If you want to ask a question, the best way to do it, on the right side of my screen, you may have moved it around on your own, but somewhere on your screen should be a WebEx dashboard. On that WebEx dashboard, there is a question box or a question drop-down. In that question drop-down, you can type your question in there. When your questions come in, I try to either interrupt the presenter if the question is relevant to what they're talking about and there's a good opportunity to interrupt them, or if your question is more generic in nature, I will hold it to the end. We do plan in some time at the end for Q&A, so if you don't see your question asked right away, I will do my best to get to it at the end, and generally we get to all of our questions. I know our last couple of sessions we had a ton of questions. We didn't get to everything. That's why I put the email addresses up there at the beginning, and I will put them back up one more time at the end. So just in case your question isn't answered today, or there's something that you think about after the session, or if you're watching this on replay and you think of a question, you'll have an email address to reach out to us. And like I said, our session is scheduled for about 60 minutes. Speaking with Adam prior, it looks like his session will probably run his talk, anywhere between 30 and 40 minutes. So as I said, we do plan some time in for questions at the end. We will leave it there for you. Future sessions coming up. We try to do this once a month. So we have our May, June, and July schedule already set. You can see the titles here of what we're doing and the dates on when they're going to occur. And it will be obviously the same time as we're offering today's session. So 11 a.m. Eastern Standard Time is generally when we offer this. Ooh, come on, one slide. That's all I want to go. There we go. So for those of you attending, if you were not in attendance live or went back and watched any of Simio Sync happened about 2 months ago. month and a half ago. Simio Sync is our annual user conference we have. The link right here will take you to that page on our website, or if you just go to simio.com, it's still on the front of our web page. Simio Sync, we featured multiple different presenters this year, from Demand-Driven Institution, or the Demand-Driven Institute, McKinsey, Northrop Grumman, Penske, and to name a few. We also had a lot of presentations from Simio on there. That was the 2024 session. We also have 2023, 2022, 2021. So the last 3 or 4 years that we've done online, all of the sessions are there. So if there's ever something you want to go back and watch, it is on that page. You can go back and watch it. But I do recommend, if you are interested in any of those speakers or any of the topics, once you kind of peruse through them, please go in, get registered, and watch the session. All right, I will turn things over to Adam. Like I said, I'll flash the screen up at the end for the QR code. So if you would please scan that and give us some feedback on today's session or future sessions, I'd appreciate that. Otherwise, Adam, I will give control to you.
Okay, great. Well, thanks everyone for joining. So the goal of this session is, from a user persona, I want to model warehouses at scale with innovative new Simio features and best practices. Why might you want to do this? So why simulate warehouses? We've seen in the market that evolving supply chain dynamics have increased the demand for warehouse automation and process improvement. So there's a large initiative happening with businesses to have leaner supply chains that are more responsive to improve their service level to customers, improve cost, and other metrics that are important to the business. Using simulation, you're able to evaluate both the design of the system and the system operation day to day. So when we think about the design, you may consider facility layout, storage capacity, or capital investments in various automation technologies or new pieces of equipment. Once you have a valid model, you can then continue to use that as more of what we would call a digital twin to dynamically evaluate scenarios related to order mix, volume, labor and staffing, and supply chain variability. So especially in a warehouse or distribution center setting, these can change quite a bit depending on the business that you're in. Maybe there's some seasonality with the business, or maybe there's some pain points in the supply chain causing variability. So the value in having a detailed simulation will really support overall the business's digital transformation effort and allow you to shift towards more data-driven insights. So I started with a bit of the why. This session is really going to be more focused on the how. So we have various materials out there. Dan referred to Simio Sync. The solution series, in my mind, is more about enabling modelers to kind of foray into these new areas. So it will be a fairly technical session, but what I'm planning to cover is, first we'll start with a data-generated warehouse template. So use the word template. This is something that we've developed that we'd like to make available to you or collaborate with you on. So if you like what you're seeing today, please do reach out to us and spark some discussion. So I'm going to show you how I integrate inventory locations through data and also order information to drive demand through the system. I'm going to talk about various configurations for modeling a rack or storage rack. We'll also use a custom add-in to build out a travel network through the storage grid. So this will be really neat, and I think something that you may not have seen before or may not be aware of. I'm also going to touch on brand new network and path planning features to help orchestrate picking activities while avoiding deadlock. So these may be especially pertinent in an automated system like an ASRS, but could also be applied in other ways. So we'll touch on that new feature set. And finally, we're going to do something that we have never done before. So I'm actually going to demonstrate some unreleased functionality called the storage bin element. I'm really excited about this. I think it's going to be a great enabler for these types of models. It's visual and pretty cool. Also data-driven, of course. So I'm going to give you a sneak peek of that and show you a little bit as to how it's set up and configured and what we're thinking for the ongoing development effort. And again, we're really looking to partner with you or collaborate. So there could be opportunities to pilot this or kind of test this functionality and get feedback to our developers as we're working on this. So I've already said data-driven a few times. This will be my last slide, and then we'll go over to the software. Just to help you think about or sort of prompt what data is relevant for these types of models. And it's pretty straightforward, but I think, as always, it's helpful to put it in writing. So key data that's going to help you on this effort. We'll think about first, demand and inventory data. So what do you need to ship? What's your order or your product mix moving through the facility? What quantities and by when? So inventory information, where are the racks in the facilities? Where do your various SKUs sit? Are there storage criteria, like they sit in various zones, or other, criteria as to how materials are stored in the warehouse? Are there totes, eaches, pallets? And again, do we have, a representation of that in data that we can leverage for the simulation model? So our templates are all meant to really be a starting point for you. And as part of the project, you really want to look at this data that you have up front so we can best leverage that for the simulation and work it in or adjust the template as needed to fit your existing data structure. Of course, this data may be coming from spreadsheets, which we see in almost every business, or a warehouse management system, or some other tool. Next thing to think about, routings, right? How do products flow through the facility? So is there a network of conveyors? Are there cranes? Are there AGVs? Are there manual pickers? Does it depend on the product type? Quite possibly. If you have pallets, right, you may be moving them by forklifts or a pallet crane or something like that. Whereas eaches may be picked into totes or carts if you have people roaming about through the warehouse. Finally, operations. So this will be sort of supporting activities. I have a version of this template basically that we're going to show you that's called pick and process. So you may have, for example, downstream activities related to kind of packing, or pallet wrapping, or pallet building that support the warehouse activities. So just generally speaking, what tasks are performed in each area? What are the cycle times, resources, or other tools that are required? Finally, other constraints. So we're going to see how we can incorporate some storage and retrieval strategies. We have a few built in, but certainly you may have your own that we could develop into the model as well, and various modes of transportation. And just a final note there, other details are certainly in play as well related to batching, quality, rework, or changeovers within the facility. All right, switch over now to the software. So the goal of this session, again, will be to illustrate innovative methods to rapidly build warehouse models at scale. So I'll spend most of my time in this model, but I have another example. And another thing to think about up front is how much detail, what's the right level of fidelity for this model? And really that should be driven by your business questions. So what are you trying to answer with this model? I always sort of challenge myself to think about that when starting a project and work with the stakeholders or your internal customers who are going to use the answers from the model to really understand what questions they have. Is it sort of a one-off analysis? Maybe you're thinking about investing in a crane, or is it more of a day-to-day, like you want to run inventory planning scenarios through the model? And that will drive your decision as to how much detail is needed in the model. So I'm going to focus on a fairly high fidelity example where we have specific inventory data stored on racks. So we'll also lean a little bit on this larger example. So you can see generally, there are two sides to this warehouse. You may very well have a project where major zones of the warehouse are just modeled using a server or servers. So we don't mean to suggest that this is the only way to do it or the way that you have to or even should do it. It should really depend on the scope of your project. So just something to think about, that we're going to focus on more of a high fidelity example and enabling features, but you may also have a good justification to do a fairly low level of detail model and still get good answers from it. And the trade-off there is that you want to build the model as fast as possible and start extracting value from it. So don't add more detail than you need to. All right, so we're going to get started. I'm going to do some configuration here to really show you some of these features in practice. And then I have sort of a slightly more built out version of this model. So it is quite a simple model, but the features I think are going to be really neat. So don't get caught up on sort of the apparent simplicity here. So the first thing I might do in this example is I want to introduce racks and inventory to my warehouse. So how do we do that? How do we typically go about that? First thing I'm going to do is just kind of a little nugget here. I want to show you a neat trick. So I already have some racks and a bit of a network built out here. I'm going to use a custom add-in. So I'm going to introduce actually 2 of these today to just quickly actually remove data from some of my data tables. So I'm going to select links, nodes, inventory locations, and storage locations. And these are tables in my model, and we're going to take a look at them to see sort of what's there. But I'm going to use this add-in to actually delete data from those tables. So there's other ways to do this. You could go manually delete the rows, or you could have it bound to an empty spreadsheet. But this is a pretty neat way to do that just with a few button clicks. You'll see some evidence that my warehouse is going to be data generated. So when I clear out that data, the objects go away, right? So if you haven't seen anything like that before, I'm just going to flip over quickly to our GitHub page where we catalog a lot of these custom add-ins, generally using our API. So that export import model add-in is totally available, freely available to you here. It's nicely documented. So again, if you're looking for some guidance on this, just reach out to us. I'm also going to demonstrate another add-in called Create Nodes and Links Table Data. That's really going to help you kind of accelerate the build for models like this. Just wanted to call that out as we get started. So the first thing I'm going to do to bring my racks back in, and this may be some data, so thinking back to that slide, this may be data that you already have. So I'm just going to import from 2 spreadsheets, and all I get so far are my racks. And I actually pulled in inventory data as well, but we'll focus on that in just a bit. So how did I get the racks? Well, I'm using an auto create table, which you may be familiar with, to create racks at specific coordinates. Now in a warehouse, I've found that there's usually some pattern to the aisles, so I can kind of determine an offset and maybe even do this in Excel, like just generate this coordinate data. Because you may be thinking, well, how do I get this, or we don't necessarily have that. You'll also see an orientation, so I can position the racks or sort of make them face, in this case, the center of the aisle. Another option there I'll just mention is you may have a floor plan, a CAD like a DWG or a DXF. I've actually used CAD tools to do a data extraction from that to get coordinate data. Now this, of course, is not a warehouse example. It's just an example of having sort of that floor plan as a CAD within the model. So for your warehouse model, you may import that as a first step, try and extract some coordinate data from it, and then you could rapidly place rack objects within the model. Now, the next thing I'm going to do will really be helpful for a larger system, but we're just going to illustrate it here in kind of a sandbox. So to build out sort of a travel network or a pick grid, certainly I could do that manually and bring sort of bisecting nodes in here and click and drag paths, but that would take some time. So we've developed another add-in to make this easier for you. And again, there's some documentation where we could help you navigate this if you're interested, but the first step will be create tables and lists. So I click yes, and these message boxes are going to tell me that I've already created those. So I sort of skipped ahead on the first step, but really what that'll do is create some sort of helper tables within your model, namely these 3. You don't really have to touch them as the modeler, but they'll sort of help coordinate what happens next. So next I'm going to create nodes and links. So the object type in this case is my rack. I'm not going to filter. That would allow you to selectively do this to some subset of racks. Node type, I'm just going to use a basic node, and I'm going to use a custom my path as the link type. Explain why in a second. So this is really the cool part. When I click OK, that's going to build out, a grid essentially within the aisles of racks that I've initialized. So you can imagine if you have, hundreds and hundreds of racks in the facility, that's going to save you so much time. Of course, there's other ways to kind of route things around, but using a network of links like this is best practice for our network and path planning features. So likely a good way to start if you're modeling something like this. Then we'll flip over. You can see I'm also using a relatively new feature for table categories to a few more tables in a pathways category. So kind of the last step here is to, let's see, my path, no filter. I'm actually going to add that network to my data table. So now I've just sort of recoded it so those objects are data generated from a table similar to the racks. And now I have a record in data. So if I had any other information like speed limit or other attributes of these paths, I could map that within the table. Finally, I've just used a custom path there because I wanted to make it bidirectional throughout the network. So that's actually established as a default value for this custom path, that bidirectional travel type. All right. So using some of these neat add-ins and data generated capability, we can pretty quickly build out a warehouse model from data, even a rather large warehouse model. So next we're going to flip over, and I've just built out sort of some supporting activity here. So we're going to run this model and talk a little bit more about kind of other data, some of the other data that we mentioned that's going to be relevant. So we'll take a look again. Pretty simple system. So you'll see orders flowing in. Orders are actually sending picks to the racks, more or less. Of course, there's kind of an inventory searching criteria that we'll look at. The picks are being facilitated by vehicles, bringing the picks to these packing areas that are sort of married back up with the orders. So I want to start this over and show you as well that I've actually used this brand new feature of storage bins on my racks to sort of visually illustrate inventory being put on or taken off of the shelves. In this case, we're just focused on retrieval. So another really neat aspect of this, let's just start from the beginning once more, is I'm going to open a console associated with, in this case, rack 1, or really any of the racks. And this allows me to sort of look inside that object and see inventory levels changing more quantitatively. So it's really beautiful, I think, that you get sort of a visual at-a-glance representation with the storage bin and more of a quantitative look inside as well, using this approach with the console. So again, just sort of getting our bearings here, and now we're going to focus a lot more on how do we actually do this. So first, I'd like to just voice over a little bit of kind of the rack decision and different configurations for the rack. So what you're seeing in this example is actually kind of a stripped down, in some sense, version of the rack. Technically, it's a fixed object. Really what we're doing is tracking inventory primarily through data. And we're only creating entities when they're ready to be picked and transported. So if you think about a large warehouse with thousands or tens of thousands of parts sitting in bins or on shelves, we don't necessarily want to model each of those as an entity sitting on that rack. It could just sort of unnecessarily balloon the runtime to keep all those entities in the system if they're just sitting on a rack. So rather, we've developed this approach to track them primarily through data, but still create entities when we need to transport them around. So again, this kind of custom stripped down rack is not built into the standard libraries, but something, again, we can make available to you through this template. Now, another approach perhaps for a more manageably sized system would be to use kind of our extras library rack object to store discrete entities on shelves. So in this case, I have a system of pallets, so the number of entities overall is not massive. So that would be a choice certainly you can make as well. Either way, a lot of the supporting data structure and the logic that I'm going to show you will be the same. We've also modeled something like a flow rack, where kind of the position that an entity was placed on the rack will affect when it can be picked off. So just wanted to start there. There's some different options for you as a decision to make kind of on the front end of your project. Now, how do we do this? So we'll flip back to the model data. I'm actually going to dock this on the side so we can see kind of both the model facility view and the data at the same time. And let's take a look first at our inventory category. So this is kind of my SKU list, right? So my material master, where I have all the valid materials, and I've actually added coloration to them as well. So that sort of helps with the storage bin setup when you see those animations. Moreover, this table is also going to auto-create material elements. Benefit of that is that the material elements have some nice features built into them, specifically for replenishment rules. So if I look at one of these material elements, we have things like reorder point, reorder quantity, replenishment policies built in to them. So you have so much flexibility there. Material is just kind of a global quantity, and inventory is more of a location-based quantity. So I could imagine there will be some questions. In the past, we've kind of used the inventory element to do what we're now doing with the storage bin. The two can still go hand in hand, where you may have an inventory element associated with the rack itself as kind of a location where I might want to replenish this material, whereas the storage bin is then one level lower, kind of associated with each shelf on that rack. So materials and inventory features is still going to be quite helpful, especially for those replenishment policies. Another thing I want to mention that you will see soon in a new release of Simio is that the material elements now have these handling and storage characteristics. So I can associate a volume per unit or a weight per unit that's going to tie in to the storage bin capacity. So we're really enabling you to get some kind of a more realistic representation of a rack and bins that are on that rack with these new features that really very excited about to bring to market. So what's next? We already saw storage locations, the rack data. Let's just take a look quickly at the inventory locations. So inventory location is now rack, bin, and material, quantity, capacity. Very, very straightforward. But I want to show you sort of a little bit more low level how we actually use this. So in a nutshell, this data is mapped to storage bins defined within the custom rack. So if I have 10 racks and 2 bins per rack, that would be 20 bins. So kind of the alternative here is, instead of defining 20 bins at my top level model, I've chosen to define those within the rack object, which makes sense conceptually. I mean, they sort of live inside the rack, so why not define them there? And kind of a disclaimer, this is not set in stone. There are a handful of different ways you can do this, and we will work to identify what we call best practices. Right now, I'd say these are following some good practices, but this is literally brand new, so I need to spend some more time as well kind of fleshing this out. But in short, I've created 2 storage bins within the rack definition, and I have sort of a helper output table that's going to allow me to track within that rack. So this is also a pretty new feature in Simio 17, to have better access to data within an object definition. So really great for hierarchical modeling. If you have models with submodels that have data inside of them, I can now sort of access that from the top level model. And I'm going to show you exactly how I do that next. So we're going to crack into some process logic. nothing to be afraid of. A little more involved in some of our point and click modeling in the facility view. But let's go ahead and redock the data for now so we get a little more screen real estate and show you what we're doing here on initialized. So I'm going to search my inventory data. This part in particular, I think, we'll choose to enhance. So you can maybe kind of automatically map those bins to the data. Right now, I'm sort of adding stock here to those bins on initialization. But again, a lot of different ways you could do this. So for each found inventory, I'm adding stock to a bin within that rack. And the syntax associated with this new feature that I mentioned is pretty neat. So I'm also going to add a row to an output table within that object. So how am I indexing into that object? So I've searched inventory locations. Inventory locations has a foreign key to storage locations. So that means each row found is implicitly or explicitly associated with one rack, defined as a primary key here. So now I can use a syntax back to that parent table to say within my rack definition, there is table positions output table. So I can add rows to it and assign that quantitative data that we saw before in the console. Moreover, for a visual aid, you'll see that I'm sort of iteratively adding stock to those bins. So the add stock step is brand new. I'll stop in a second, just click in so you can take a look at that as well. But we'll just do a few more steps to see that I'm going to go through one line at a time and add inventory to those bins. Pretty neat. And just to round this out a little bit, we'll just take a look at the add stock step. So again, I'm using kind of a data-driven way of doing this to take the material from the data, the quantity from the data, and index into the correct bin within my rack. So not a ton to this, which is nice from kind of an adoption standpoint. Should be fairly easy to pick up and run with once it's released. All right. So let's take a look next upstream and focus a little bit more on the orders or the demand. So we've seen now more or less how we're bringing inventory data in and mapping that to bins within the rack objects. So I run the model. Let's just watch again. So orders are coming in. Some of them are fulfilled and sort of move over to the combiners. Some of them are restricted or sort of hanging here on the left side. So where do the orders come from? Well, the answer, as usual, is data. So we'll switch to the orders category and start with retrieval orders table. Just made up data here. I've introduced 20 orders to the system with a specific arrival time. Moreover, each order is mapped to a number of lines associated with that order. So to fill order 1, I need 3 units of material 1 and 5 units of material 3. Keep in mind, you may also, and I have before, used more of a mix and volume-based approach as opposed to order-based. So if you're working more of a push system or you wanted to model it that way, maybe you're doing kind of wave picking or some other method of picking, you could certainly rework this. So it doesn't have to be order-based. There are other ways to do this. So next, we'll look at this order allocate server. Helpful to have sort of a place for order management, more specifically to initiate picks. So setup is not too involved, at least on the object itself. So I set it with capacity of infinity. So anytime an order comes in, we can consider if its picks are available. And how do I do that? With a one task sequence that's actually executing a process where I'm going to implement the retrieval logic. Now this will look a little bit involved, but this is part of the template that I'm referring to. So I reworked the template and actually simplified it a little bit for this example. But this retrieval logic is something that we have templatized, so it's something you could kind of take as a starting point and modify as needed, which is what I've done on several projects so far. So what does the logic do? So this is now for an order in that server, right? So when I run, we'll see I'm checking order entity 112. If I hover on these entities, you'll see their IDs. So the first order in the system, order 1, is now executing this logic. We'll see that there are 2 lines associated with that order for each one. I do some kind of row referencing help. Mainly, I want to get to this search inventory step. So this is where now I have an ordered line associated with a particular material. So that was actually the set row that we saw in the process logic to say, set row for that token to a particular material, the material actually that's associated with that line, because now I can efficiently index into my inventory data through that primary foreign key. So to summarize what this logic is doing is if I need to pick, let's see, we'll go back to our orders, look at order 1. If I need to pick material 1, I'm only going to search inventories associated with material 1. And when I look at them through this view, you see 1, 2, 3, but they're actually in rack 1, 3, and 7. So that foreign key allows me to efficiently index into this table, which could be rather large. I mean, you may have 10,000 rows or more in this table, depending on how large the warehouse is. So kind of efficiently indexing into that is an important concept. And then just to round this out, for that pick, I'm going to create a different type of entity and transfer it to the rack output node. I also manage the quantity on that entity as well. So pretty flexible. And then finally, we're checking if everything was found for that order. You can release the order to the packing line. If not, it will be delayed. And that's again where, depending on your project and how you do this, that could look quite different. So an opportunity really there to customize how that's being done. So we'll see if we take off that breakpoint when we run. A number of the orders are able to be fulfilled. Some orders have to wait. And we could actually track that back to if we look at order 5. Retrieval orders, order 5 needs material 5. It actually has 2 lines of material 5, which is just a feature of my made-up data. But if we go back to look at material 5 in our inventory locations and maybe filter down to material 5, we'll see that its quantity has dropped fairly low. So we don't have enough to fill those orders. So hopefully here just illustrating a simple example of some of these important concepts for warehouse modeling. Now I'll mention as well that you could use a similar order-based methodology for storage and put away. So I've just focused on retrieval, but part of that template is put away as well. So that could also be order driven. If we go back to the orders data, you may have put away orders and put away lines, or using replenishment policies or some other means. Pretty similar in the sense that you would have eligible locations in data for the materials that you're putting on the shelves and searching criteria as needed. So to illustrate that, another thing that we've built into the template are these rules. So my default is closest. So my first pick is going to happen at rack 1. This is going to be closest amongst those eligible locations. And it's actually a part of this search step. So the rule that we select from that property affects the way that this search is performed, sort of the direction of that search. And you can also see a helper table that defines the expression associated with those rules. Pretty neat. We built a few in there related to quantity and capacity. For simplicity's sake, I'll just switch this to farthest, and you'll see that that first pick happens a bit farther away from where the vehicle initially was, just to show that this is responsive to those inventory locations. All right, doing pretty well. So we'll round out this model I have also implemented network and path planning features just to avoid deadlock, although there are only 2 vehicles. This will really be more pertinent when you have a larger system with bidirectional paths all throughout the network. So we're going to flip over and clear my model results. There are no spoilers on my dashboard. So when I turn the visibility on, you'll see that there is a fairly comprehensive grid now through a larger system of racks. And actually, when I run it, you'll see that these paths are, in fact, bidirectional. So just looking at this system that is automated, quite a bit of opportunity for deadlock as these vehicles compete to get to their destinations to first pick and then bring things out to an induction area. Let's just run this. I want to show you another fairly new technique using this heat map dashboard. So I've turned on live data refresh, and you'll see while the model's running, it's paying this dashboard to show me in real time congestion throughout this network, which is really pretty awesome in my opinion to see that play out in real time. And certainly you could also just periodically update that if you'd like as well using reload or pause. But the idea here is that vehicles circulate into the grid. We'll just take a quick look in 3D, which we may have already seen, and then go back out. But they'll wait until they can ensure a deadlock-free path back to their destination. And that is done using those network and path planning features. Now, I'm really just going to pause there and point you to another reference material. I did a very comprehensive presentation on this model as part of our last Simio sync. So if you're more interested in network and path planning or sort of use cases and the why you may do these warehouse models, I run some experiments and some optimizations in this presentation. This would be a great reference for you. I will illustrate one such scenario just while we're here. So when we run the model, you'll see that the pallet storage is fairly randomized. You may have already noticed that, but we'll just do it again. Going just by coloration, you can see that green, yellow, and blue, not a ton of rhyme or reason as to any kind of sortation associated with them. But I can change that by running a data-driven scenario. So you'll see in this model, redoc results, so it's out of our way, I have a similar inventory table. It's made up of material, pallet type, and rack location. So very similar to what we saw in the simple example. Now I have this bound to different data sets on my device, and to send a different file, I've created a model property that indexes into my data connector. So when I switch product type there, it updates the data connector, and this allows me to actually build scenarios off of different file names. Really a handy technique for any sort of data-driven scenario analysis that you might want to perform. And in that Simio Sync video, I walk you through all 3 of these experiments and run them and see the results. We actually throw the results on Portal, which is our web-based tool for democratizing access to models and viewing results. So a lot to be had as well in that video if you're interested. The point I'd really like to make here, as long as I've spelled it properly, is when I run now, you'll see that visually I am pretty dramatically changing the inventory configuration, right? Now we've sorted by product type throughout the warehouse. And the idea would be I'm an inventory planner who wants to consider, in this case, probably from a design perspective, this would probably be a decision that you settle on. But using a similar capability, you could look at more day-to-day scenarios by piping data through that model as it changes. And also a really quick how-to on that heat map dashboard, if you're interested. Could be good for any automated travel network or congestion analysis that you're interested in. So I'm using the state observation log. I filtered down to just one vehicle, and I'm logging X and Z location at some interval. And I'm driving that from within the vehicle definition. So within that vehicle, I have two state variables, current X and current Z, associated with state statistic elements that are optionally, this is just mapped to a true or false logging. And they'll log their position information at some interval, and that becomes the data source for my dashboard. They're only logging a new row if the position changes. So that's why you get the duration reflected as green, yellow, or red in a certain position as well. One other thing I want to leave you with, and then we'll break for questions. Another thing I modeled in this space is the idea of a pick list. So in both of these examples, you've seen the vehicle go to the rack, pick one thing, and take it to a destination. Probably not too common, actually, in a warehouse setting. You may wave picks or assign a list of picks to a vehicle or a person with a cart, for example. That is something I've modeled, so if that's pertinent to your application, reach out. We can collaborate on that as well, where I use essentially an output table to write a list of picks, and then I modify the way that the vehicle works. So once it grabs something, it checks the next item in the list, goes to that destination, and of course, in that case, the vehicle would have some greater than one ride capacity. I did this in a cart picking example where the carts could hold up to 150 items. It's really neat because you see the person move through the warehouse and fill their cart and then take each of those items to their destination. I figured I'd leave you with that as well as another good concept. So that's all I've planned for you today. Just switch over to our final slide. For further learning, let's collaborate. Please reach out, and we'd love to start a discussion with you. And thanks a lot for your time and attendance. Happy to take any questions now.
Perfect. Thank you, Adam. All right. And as I mentioned at the beginning, if you have any questions that weren't addressed during today's session, please feel free to, in the WebEx dashboard, somewhere on your screen, you should have it. There's a question drop down. Just type your question in there and we will try to get to it. We have about 10 minutes left in the session. Adam, I've got maybe about 6 questions here, so let's see if we can get through these. All right, start off. Can the table-based path creation be adjusted for ArcGIS Worldview? Question, can we use the auto creation of paths on world maps?
Yeah, with that add-in, that's an interesting question. So the map features have a capability to build links out on roads on the map. So I think actually what you would look for is probably not this extension. And take a look in the GitHub because there is a GIS related add-in. So these are examples that we've developed that I myself have just been getting a little bit more comfortable with these and how we build them out and the code associated. If I click into any of these, and to avoid fumbling, I'm going to click into one that I know. So if I click into one of these examples, I can navigate through, in this case, executables. Oops, let me find the right category. Actually, I want this folder. I can click through and actually see the code that is behind ultimately the DLL that I load into my install to get the add-in. So the reason I have a different ribbon button is because of that DLL that's placed in my build that get the DLL from that code. So take a look at what's there. I think it would probably be a different add-in. We do have one related to GIS, and let's potentially follow up on that one. Good question.
Okay. All right, next one. Can you create multiple general networks and then assign to each specific vehicles/material handling equipment to use each network?
Absolutely, you can. Yep. So I think a common example of that would be maybe you have a combination of automated vehicles picking and human pickers. So they may each be on their own network. And there is more on the network setup in that video, so check that out as well. But when I look at the network element, it can be data-driven to create a mapping of links to network. So in my links table here where I'm auto-creating the paths, I have a foreign key for network. So you can map different links to different networks. And this is actually covered in the Symbit as well. So take a look at support Symbit's network element, and I know that Symbit covers multiple networks in one model, exactly for the application I mentioned, where you have an automated vehicle network and a human travel network.
All right, perfect. How does the model decide what vehicle to seize if there is a tire conflict when selecting the vehicle? Is there standard behavior logic set up for AGVs?
Yeah, so the vehicle transport requests are by default on demand. So the vehicle has a couple different, I want to use the right word, routing types. The default is on demand. The other is fixed route, more like a bus loop. If you had some kind of trolley or tugger system, you may use that fixed route option. And then the transfer node, where I'm dropping those products when they're ready for picking, specifies which vehicle. So if you had different types of material handling devices like AGVs and cranes, that would be specified here as to what vehicle. You can also select from a list to have more criteria if both could potentially pick from here, but you want to have some condition as to, hey, if it's this product, use the crane. If it's this product, use the AGV. So short answer is yes. And that pick list methodology I referred to would also be helpful here. So when I run the model, you can see there's 29 vehicles in this population. That pick list method with an output table allows me to actually assign picks to each individual vehicle. And in that case, you could use any criteria that you want. But right now, it's fairly on demand. So when a vehicle becomes available, it checks sort of the global queue of what's waiting, and it goes along.
Okay. All right, this one's similarly related. How do vehicles move on the network without crashing into each other or blocking each other?
Yes, that is the proprietary goodness of the network and path planning features. So let me think of a way that I can summarize. That path planner element is applied selectively to nodes in the network. You may choose to apply it to every node in the network where the vehicle may stop. When it hits the path planner, it will reevaluate whether or not it can get to its destination deadlock free. You can also add criteria on the path planner as to some condition that must be true if you want to replan that path. So I've said here, essentially, if you already have a planned path, don't replan. But it's a good question, and the quick answer is that there are features built into the path planner and techniques as to how you use that. So another example is on the links, specifically this kind of recirculation loop, I don't allow passing. So the first vehicle will wait there until it can ensure a deadlock-free path to its destination. I run a scenario, however, where I do allow passing, and the setup or the storyline associated with that is that the vendor of this system offered you a parking station at this recirculation point that has a cost associated with it. So this allow passing recirculate scenario that has a higher cost associated, but you can see the impact on throughput. So in that scenario, I allow vehicles to stack here more or less. So if the first one's blocked, they don't all have to wait behind. That first one can pull off and park in the others. So half modeling techniques, half features that we have in there, but a lot of flexibility to get what you need. What we see a lot is that AGV vendors don't always share their routing algorithm, even with a customer or systems integrator. But we have heard from some initial applications of this that using these features was a good way to replicate the system behavior. We're always trying to model or represent some real behavior, maybe without total knowledge of what the algorithm is or what it is. So yeah, great question there.
All right, we have, I think, time for maybe one or two more. Let me get to the one that's on top, and then I know questions are still rolling in, so I will pop up our email addresses just in case we don't get anything answered. What's the expression that returns the number of entities that have traveled on a path/time path/connector?
Number that have traveled on it. I like that. That's a good on-the-spot question. Let's take a look and see. And in the spirit of showing you techniques that I use, when I ask myself, what is that expression, I'll often pull out a status label. I have that on a different layer right now, so it's visible at first. So let's see if I do my path, what was it, 1048. Number travelers would be the current number of travelers. So in the spirit of getting to some other questions, I would say take a look at these functions, shoot me an email, and we can iron that out. But you do have some options, and this is generally how I check that for myself. I say that mastering Simio is not about knowing everything, but knowing how to find the things that you're looking for. So yeah, let's take that one offline.
All right. I'm going to ask one more question, Adam, and then we'll wrap up, and I'll flash our email addresses. Question is, can I define my own selection condition rules for routing types or AGVs?
Yes, you certainly can. And touched on that a little bit with the condition that you can apply on transfer nodes. I purposely kind of buried them under the racks, which makes them difficult to click. But the nodes have a selection condition as to what vehicle should come. The vehicle also has a task selection strategy that you can use to triage where that will go next if there are multiple eligible places to go next. So some good options there using those two features to kind of filter with the condition or apply a strategy or a preference.
All right, perfect. All right, and in the interest of time, let me grab control back here and just show our email addresses and the QR code one last time here. So, all right, email addresses. So there's my email. There's Adam's email. If we didn't get to your question today, we do apologize. We've simply just run out of time. We had a lot of great questions, a lot of people here today. So if we didn't get to your question, please feel free to email one of us or both of us, and we will get back to you individually. And on the bottom of this slide right here, once again, the QR code for some feedback, some survey information based upon today's session and future sessions. So with that, we are right at the top of the hour. Thanks everyone for attending today. We really appreciate it. One last time, our next session, May 16th, so just about a month from now, on counter element new feature and other elements, time monitor, etc. That'll be on what is May 16th? Just confirming, Thursday, May the 16th at 11 a.m. Eastern. We hope to see everyone then. Thanks, Adam, for your time today, and we'll see everyone in a couple weeks. Goodbye.